Hello, everyone. My name is Meike Ihlbrock. It's my pleasure to greet you this evening to our ESMT Open Lecture on ethics and AI. I think it's, really interesting. Everyone's like, oh, AI, oh, chat GPT, and oh, let's write about it, talk about it. We put this as one of our 3 focus themes in ESMT communications this year. And we are really, really happy to have then Meike Zehlike, Dr. Zehlike here with us this evening. So we hope to gain a better understanding of ethical considerations that need to be taken into account when developing and using AI. I'd like to take a moment to also welcome our guests who are in the stream with us. I hope that you have a great evening as well. Dr. Zehlike is a senior researcher at Zalando and has extensive experience in the field of AI and its ethical implications. She received her PhD, summa cum laude, from Humboldt University in 2022. Her doctoral research focused on fairness and discrimination in rankings and search, and she has received various grants and awards for her research. I'm just going to name a couple. It's crazy. She was a Google Women Tech Maker Award. She got that in 2019. A data transparency research grant in 2017. That one is for me like, ooh, data transparency gets me all kind of nervous about what I should be doing differently. Maybe I'll learn a little bit today. In addition to her position at Zalando, Dr. Zehlike is an external lecturer at Humboldt, a freelance consultant for ethical AI for German labor unions, and a contributor to the German AI standardization initiative. So we're joined today, also very excited, by Dr. Urs Müller. He is an associate professor of practice at SDA Bocconi and affiliate program director here at ESMT Berlin. Urs is an experienced educator and author in the areas of business ethics, strategy, and change management. And I have to say, Urs is my go-to guy when I really don't know what should we do in a certain situation. He studied philosophy, literature, and art history, and he's been teaching executive education and degree programs for many years around the world. We're very much looking forward to a very lively discussion, and so I'm going to turn over to Meike Zehlike.
Yeah, hi everyone. Thanks for the introduction. Okay, let me check. There's some funny stuff here. Okay, great. So welcome to this introductory talk on responsible AI, which, as it was introduced, I already do for quite a few years now. And it's a discipline that, asks how can we build inclusive and fair AI systems. I'm probably going to skip that part. You've already heard a lot, but if you want to follow me on social media, this is how you can do it. And this is what we want to do today, right? So first, I want to talk about what exactly is AI and how does it work to get everybody on the same page, because I hear it's like a, general public. I'm not assuming anyone actually knows how AI works. Then the next thing we're going to talk about is some ethical foundations that have been used in the responsible AI field. And I will walk you through how you translate these ethics into math, very on a high level. So no worries. And then in the end, we're briefly going to cover like, okay, given that we have all this knowledge now, like what do we do? Okay, how does it work? Interesting. Okay, anyway, good. So first, AI is everywhere and it also determines our fates, right? It is probably not very new, but a few years back, it was very new that it actually determines our fates, right? People were like, yeah, AI, I don't know, I've heard about it, but I haven't really seen it, but it's actually everywhere, right? It determines the access to news that we have and information. It determines our creditworthiness, and then in turn, whether we get credit or not, or to what conditions we get credit. It does CV screening. We do job performance evaluations in some companies. Like if you work with Microsoft 360, Office 360, I think it is called, there's like all sorts of like integrated performance evaluations on this. Most of them is luckily covered by the German labor law. anyway, like AI causes these echo chambers on social media. There's biometrics used at border controls where people have problems if they have dark skin or if they happen to be transgender. It's also used in resource scheduling of various types. It's used in medical diagnosis support, and everywhere this stuff has caused problems, right? And it turns out after quite a few years that, I mean, these systems were implemented in many cases because we thought like, okay, let's get rid of the human bias, right? Like judges are not really good at taking decisions, particularly when they are hungry. So let's place an algorithm there to get rid of that problem. And people were like, okay, perfect. And then it turned out like, oops, did not work as well. Good. The good things about this is, of course, it does simplify our lives, right? And these are some examples of applications where I think AI is doing a great job, right? We have like natural language processing where we can translate from one language into another very easily today, right? Like you can communicate with people where you don't have a common language through Google Translate. We have Google Maps for a very long time already. We have access to, as I said already, all sorts of information, like basically all human information that is in the internet is accessible through various search engines. So it does have a lot of benefits, but it also has quite some risks. And these are that AI is used in contexts where, as I said, actual human lives are at stake. While at the same time, no one really knows how a decision was made and based on what. AI has been proven by now to promote and exacerbate bias and discrimination that originates from our society. And the amount of AI snake oil these days in certain domains, particularly in human resources, this is why I have this example here on the slide, is just absolutely mind-blowing, okay? So there is not just good systems out there. That's what I want to say. Not all of it is beneficial, actually. Some of it is just snake oil. Okay, but how does it actually work? Like, what is AI and what is machine learning in particular? Because this is what most of the media articles and stuff talk about. Okay, so in traditional modeling, what you have this like single phase that they call prediction in this slide. And you have some input data, and then you have some handcrafted model that would be like the code that you write. And then you put all of this into a computer, and then the computer calculates some result based on the input data in the model. So let's say the model is A times B, and then your data is A equals B equals 2. So what you would calculate is 2 times 2, and then it spits out 4, right? Now in machine learning, what happens, you have this additional phase that is called the learning phase. And what is different is that this time you have input data and you have the expected output. And I ask the computer to find the model for me. So if you want to find this multiplication example, you would have input output pairs such as A equals 2, B equals 2, result is 4. And then another one that could be A equals 3, B equals 3, and the result is 9, and so on and so forth. You have a lot of them. And then you ask the computer, like, go and find me the function that best approximates all these so-called training examples. Okay. And once I have found this model, then, I can take it and use it again in a similar way as I did before in a prediction phase. So in this second prediction phase, I have some new data. I have this model that I did not handcraft myself, but that the computer found. And then the rest is very similar. I put it in the computer and then spits out the result. And we hope that this model that is found there is actually resembling the model that we were looking for. What does this mean? We need a lot of data, because even just finding such a simple function such as multiplication would require us, let's say, at least 10 or so examples to be really sure that what we are doing there is actually correct. And the more complex the tasks get, the more data we need. And there is an actual formula that helps you to calculate how many training examples you need to have like a certain percentage or a certain probability that your model will actually be correct. And this is a little bit shown here in this picture on the right. So it tells you the error that your model makes decreases with the sample size. And this is also how you end up in the end with knowing that you have the right model, because your error sort of, or your loss function sort of saturates on a certain level. So you do not lower your error anymore. Okay, so this is how AI works on a very high level. Now, if we want to go into ethics, the first question is, of course, okay, what's the problem? Why do we even have a problem there? The first problem is that the models don't really work, okay? And why is that? Like I said it before, that we need a lot of data, but there is certain groups of people or certain groups of situations where we just don't have a lot of data. And this is particularly true for minorities, because otherwise they would not be called minorities. And what this means is that for the minorities, the models work, if they work at all, it is very likely that they work a lot worse. And this is illustrated in this picture here. So you have like a lot of dots. You have this one group where there is a lot of dots, and the green model is the model that we actually want to find. The red model is the one that was found by the computer. And we see that in the top right corner, these models are actually pretty well aligned. So it's working relatively good. But in the other case, the model that we would actually want to find again is the green one, and it does not resemble the red model at all. Okay, so it makes a huge error for the minority group. And again, this is quite straightforward because we don't have as much data about minorities. Yeah, that also relates back to, you know, error versus sample size thing. If you don't have enough samples, then the error that you're going to make is going to be larger. Okay, so this is the problem that you have on the data side. But another thing is also that what I said already, people were thinking that math is actually value neutral, but then it turns out it's actually not. And I'm showing you this formula because this is in essentially how I would say 99 or 95% of all machine learning models work today, right? They minimize a loss function, as I said, so they minimize the error that they are measuring. And the way they are measuring the error is usually Euclidean distance. This is what the Euclidean distance is, right? So you have an example that you give from the training data set. This is Y. And you have the result that the model produces right now. Okay, so you guess a certain model, you give it a training example, and then you let the model calculate something, and then you compare the two results. And if the difference between the two is small, then you think like, okay, the model is pretty good. And now you do this for all of the examples. And then you sum this whole thing up, and then your assumption is like, okay, if this summation is minimal, then I have the best model, okay? This is what this formula means. And again, that like this is how 95% of models work today. And the thing is, like, if you think about it in like philosophic terms, this is actually related to utilitarian ethics, okay? Because you minimize the sum of the individual losses, and you try to find the model that sort of like works best for everyone, but you don't care how bad it is for one individual, okay? So this formula is by no means neutral. It doesn't mean that it's bad, but it is utilitarian ethics. It's not value neutral, okay? Good. So, and then what ended up happening with all of these problems is what we have all seen in the news, right? And these examples of AI bias actually cover, I don't know, everything: hiring, housing, security, ad serving, search results, face recognition, you name it. And so the question is, what can we do about it? But before we go into this, I want to give a particular example on how much bad AI can actually affect us again, because this is one of the European examples that is very, very interesting and also very, very disturbing. So there's this AMAS algorithm that was developed in Austria and was meant to be used in Austria for the unemployment service, where it was supposed to be assisting unemployment caseworkers to distribute resources in a certain way, right? So it is a classification algorithm that had 3 main goals. It wanted to increase efficiency and effectiveness of the consultation. It wanted to improve the effectiveness of the support measures. And it also wanted to standardize the support measure allocation and prevent arbitrariness, right? So everything is sort of, let's say, it's comprehensive, and it also is not meaningless like in its in the goals that it had, but it has a very strong focus on efficiency. And also, it turned out that it was actually never checked whether these goals were met at all, but it ignores a lot of other things that comes with problems with this. So what this does, it classifies all job seekers into 3 categories, which is high, medium, and low chances to find a job within a certain period of time. And all the support measures will then focus on the medium group, because the assumption is that everybody's in the high group is going to find stuff on their own. They don't need support. Everybody who's in the low group, well, we can't really do much for them anyway. And it was not quite clear what was actually the result then. I think they were sent to like some sort of other institution, but anyway, the main focus was on the medium group. And then these people would get into, I don't know, all sorts of trainings, consultancy on how to place themselves on the job market, et cetera, et cetera. So then there was this study by Doris Alhütter and others who were going through the documentation, everything, and were talking and were presenting, okay, what is the feature set of the algorithm? This is where it already starts. So we see a bunch of features that are related to demographics, except for this thing here, the 4th one that is called education, but that only asks whether you have a Pflichtschulabschluss, which I think is related to Realschulabschluss in Germany, so after 10th grade, if you have an apprenticeship, or if you have a high school degree that allows you to go to your university or not, or if you have some sort of higher education, right? And what else? Yeah, so I think there was another thing that was related to qualification. I don't find it right now, but anyway, I mean, 14. There are 14 features in total, and only 2 of them are related to any sort of qualification. And then there's this interesting feature that is called caregiving duties. And this feature you can only assign to women, right? So men cannot have this feature, even if they are fathers, it doesn't matter. And then what this study does is they were creating 2 artificial persons with the age of 34. Both of them have the same education, apprenticeship. Both of them have the same job market segment, which is production. The only difference between them is the sex and the caregiving duties, which again cannot be assigned to men anyway. So we have these 2 persons is a woman with caregiving duties and a man, and we don't know whether or not they have caregiving duties. Now, the result for the man turned out that the short-term chance to find a job again was assigned 66%, the long-term chance 72, and therefore the person was assigned to the high class. This means you have long control intervals and no mandatory coursework, versus the result for the woman ended up being, significantly lower. Therefore, she was put into the medium class. And again, this was the same person, right? The only difference was sex and caregiving duties. And because she was assigned to the medium class, she would be put into short control intervals and mandatory coursework. So she has, despite having the same qualifications, she has a lot of more stuff to do. And also despite having caregiving duties. And so you see that this algorithm is sort of treating the same person essentially very, very differently just because of their demographics. Okay, probably going to skip this. Just shows again that this, this algorithm is even more discriminatory if it comes to intersexual discrimination. So if you look into women with migration background, it gets even worse. Okay, now let's talk a bit about ethical concepts that we need to know so that we can actually, that we have a vocabulary to talk about what's actually going on and why this is a problem. The first one is prejudice. So prejudice is an affective feeling towards a person based on their perceived group membership. And yeah, the word is often used to refer to some preconceived and usually unfavorable evaluation or classification of another person based on that person's perceived group membership, right? And the important point is that it does not necessarily have to be the group that they would assign themselves to or that they are actually in. It is perceived group membership, okay? Then discrimination is the act of making these unjustified distinctions between people based on the group membership. Okay, so I'm actually putting my prejudices into practice. And then oppression, in turn, is a malicious or unjust treatment or exercise of power, which then comes under the guise of governmental authority, but it is actually sort of like a systematization of discrimination. Okay, so this is the difference between prejudice, discrimination, and oppression. And the interesting thing is that these three actually form a cycle. I know it's not very easily visible, but the important picture is the one on the top left. So you see that prejudice leads to discrimination, leads to oppression, and then this again leads back into prejudice. And this is exactly what happened in the AMAS algorithm, right? Because we are assuming that women are, well, first we assume women are better caregivers. Therefore, we are assuming that they, for some reason, want to stay home, and therefore they are worse workers. Therefore, they have worse chances on the job market. And then we put all of this into an unemployment system, which reinforces all of this, okay? So it's really important to understand that these three things do not exist individually, but they form this, yeah, a cycle of oppression. Okay, and now that we know that, the responsible AI community has started to talk about different normative principles to first counteract that, and also, yeah, to make algorithms more aware of these problems and implement some sort of morality or idea of ethics into the algorithm itself, because they were setting out to counteract all these systems that didn't work properly. And what they do is they usually distinguish between what they call individual fairness, which is also related to equal treatment or formal equality of opportunity. We're going to come to this later. And the other fairness thing they talk about is called group fairness, which is more related to egalitarianism or to substantive equality of opportunity. And again, I will explain this in a bit. But these are the two central concepts that responsible AI people usually talk about. Okay, so equal treatment means you want to treat likes alike. So in the case of the AMAS, we want to treat these two persons who were differing only by their demographics. We would have wanted them to get the same treatment because they had the same qualification. This is what equal treatment is, the thought behind equal treatment is. And, you know, if you want to think about it in a more funny kind of way, then you would think like, okay, everybody who is reasonably hungry gets a cupcake. However, the problem is that people might be equally hungry, but let's say we have a person A, they already have 2 cupcakes that their dad was baking for them in the morning, and then person B already has a cupcake which was given to them before, and only person C doesn't really have anything yet. So if we give equal treatment to all of them, then we would end up with a very different outcome. And the question is like, is that justified? Do we want this or not? And there are situations where you would say, okay, fine. There's also situations where it's say, not so fine, actually. So what are the limitations? If you treat everyone the same, this is only fair, obviously, if and only if they are starting from the same position. But in many cases, and in many important cases, when it comes to chances in life, you know, access to education, access to jobs, et cetera, even access to credit, not everyone does start from the same position, and therefore equality must be put into a social context. And this is where egalitarianism sort of comes in, and it asks like, okay, what is the social context? What is the benefits that you have seen in the past? what was your privilege in the past, and based on this, you get assigned cupcakes in this case, so that the outcome is similar in the end. So egalitarianism assumes that not all people start off from the same position, as I said. And because of this, the assumption is this makes it much more difficult to be successful. And so egalitarianism seeks to address these inequalities that stem from an individual's particular circumstances. So this is the idea of what is also called leveling the playing field, and is often referred to as equality of opportunity. Okay, and then equality of opportunity comes in two different flavors, of which the first one is formal equality of opportunity, where individuals should be judged only by attributes that are relevant for the position. Okay, so you should not be judged by your gender or by your skin color or anything else, but only by the attributes that are relevant. However, this is the critique, the opportunities to develop these merits are also not equally distributed. Okay, it depends very often, like what school do you go to and what learning resources did you have access to, etc. And therefore, there's different flavors of substantive equality of opportunity, which says that society should do what it can to level the playing field among those individuals who compete for positions, so that the potentially relevant attributes can be equally considered. Okay, and then there is Rawlson equality of opportunity. I'm just going to skip that because the more interesting thing for the later part of the talk is luck egalitarianism, which says that all of those inequalities that do not stem from an individual's voluntary choices, but only from brute luck, either social luck or natural luck, should be corrected. So this means if people are worse off through no fault of their own, such as being born into a poor family, then this is unfair. And if people are worse off as a result of their informed choices, then this is fair. Okay, so it points to responsibility, because victims of bad luck should be compensated, while those who gamble and lose should not be compensated. But then again, it's a bit tricky because it's not really easy to distinguish between inequalities that result from personal choice versus bad luck. And again, this points back also to the AMAS. If personal choices very often reflect your background inequalities, such as where can I afford to live? Or do I have to work part-time as a mother, even though this lowers my salary and then lowers my credit worthiness, but I simply can't find any caregiving facilities that would allow me to work full-time. Okay, and so if we apply all of this to algorithmic decision-making, this means that a fair system should correct inequalities which are not the result of personal choices in certain scenarios, while at the same time allowing for inequalities that result from free choices. Okay, so if you think about the AMAS again, it was not simply unfair because the result discriminated against women, but it was also unfair because it used variables that did not reflect individuals' personal choices, such as living in a certain neighborhood, again, where there is higher unemployment rates, for example, because I can't afford to live somewhere else. Okay, now, if you know all of this, how can you translate it into math? And I'm gonna quickly go into parts of my own research from my dissertation and a comparison to another algorithm that's used today at LinkedIn. So I wrote this paper that was called a fair re-ranking algorithm. And there our idea of what is a fair ranking was a representational idea. So it points into the luck egalitarian direction. And both of the algorithms that I'm presenting actually were setting out to be part of this luck egalitarian framework. Okay, and our definition of fairness in a ranking was like, okay, let's say you have blue and red dots and you want to distribute them fairly in a ranking, then the very left one would obviously be very unfair because there is no red dots at all in the ranking, right? But then the ranking in the middle would still be relatively unfair because all of the red dots are now at the bottom. And I mean, we know that everything that is on the second page at Google doesn't exist, right? So being in the ranking doesn't necessarily mean that you will be considered. The same is true for LinkedIn, right? Like if you're not in the top 10 positions of candidates for software development as a woman, because the computer learned like, yeah, you know, like women are not really developers very often, then you're out of the game. You will never get, interview requests from headhunters. And this also in turn creates a reality, right? So it's not that this stuff is benign, because if you never get asked by recruiters if you want to join a certain job or only jobs that are not so interesting, you will actually become less employable over time, because you don't get access to the good jobs, you don't get access to the interesting things, you don't have as many choices, et cetera, right? So it's a self-fulfilling prophecy in a way. And then we said like, okay, if we want to have a fair ranking that is fair, like in a like egalitarian way, that means we need like a certain amount of representation of these red dots here. And it has to be distributed in a relatively fair way. And this would mean that the ranking should look more or less like this. And this is the idea for both algorithms that I'm going to present. Okay. So what the algorithm does is you rank all of the candidates from all of the groups separately. And then you determine the minimum number of protected elements. So there's this notion of protected groups. These are usually groups that are somehow protected by law, such as, you know, demographics that are protected by law, such as disability status, gender, etc. Right, so you have all of these groups, you rank them separately, each of the candidates, and then you determine at each position, okay, which group should I put next? And we basically, I mean, it's mathematically a little more sophisticated, but the statistical process behind it is that we roll a dice, basically, right? So we roll a dice at each position, and whatever side is showing is the group that we put. Okay, and then you can calculate, given this statistical process, you can calculate like the minimum number that you need at each position from all of the groups. And once you have this minimum number, what you can do is you check for every position. If I already have enough protected elements from all of the group, I just take the next best one from qualification wise who's available. And if not, I roll a dice which group to pick, and then I pick the best one from this particular group. Okay, and then there were some other people who got inspired by this algorithm, and then they implemented it in LinkedIn, and it's still actually in LinkedIn today. And this works relatively similar. It also ranks all protected candidates separately in their group. And then for every position, it checks whether this group has, it searches for all of the groups that have not yet met their minimum or exceeded their maximum yet. And then again, if it determines that, okay, there's already enough protected elements from all groups, it just simply picks the best one that is available from everywhere. And otherwise, and this is the difference to the first algorithm, if it sees that there are several groups that would be eligible for this one position, then it takes the best one that is available from these groups. And this may seem like a very, very tiny difference, but it actually blows up the entire like egalitarian framework. And I'll tell you in a second why. But yeah, let me quickly compare the two. So again, they are really, really similar. And they are also really similar in terms of the user interface, right? And in terms of the programming interface. So if you want to implement any of these two papers into your system to say like, okay, I have a fair ranking algorithm, then these two things will look almost exactly the same. Okay, so both are post-processing methods, both have these very similar re-ranking procedures. And as I said, the interface is also very, very similar. But the LinkedIn algorithm does not comply with luck egalitarianism. And why is that? Because it compares across different groups of candidates, right? Because if several groups are eligible, let's say like I could put either a woman or a disabled person, I'm going to take the one that has the better qualification. And what this means is I start to compare protected groups against each other. And this is not compliant with luck egalitarianism. And it is also not compliant with intersectional discrimination. Because if I say like, I have, let's say, white women, black men as protected groups, then it is very likely if I do this procedure that I will always choose the white woman, because she's from all of them, probably depending on country, but you know, in a white majority society, it's very likely that the white woman is the one that is the least discriminated of these three. And intersectional discrimination states that if you are at some intersection of different groups, such as being a black woman or a black disabled woman or something like this, you face discrimination that is very, very different first. And it's also not just additively compounding, but it compounds in a very bizarre, and usually it is also much worse. So, and this is what the other algorithm does not do, none of the two. And the important point is that, again, these two look so similar, and they only have this like one tiny little difference, right? And it's not even like a difference in the fairness definition, it's more like a difference in the design decision of the implementation of the algorithm. But still, from like a philosophy point of view, they're entirely different. So, and why is all of this so very important, and why am I telling you all of these details? You know, sometimes like, oh, come on, I didn't even understand it. But the point is that every technical choice you make is always a normative choice, okay? You cannot make non-normative choices in your life, ever. Taking the bus is a normative choice to a certain extent. And it's important that we acknowledge this and we understand that we just can't say like, I don't have to deal with this sort of stuff because it's not part of my work. Like it's always, if you do technical choices, it's always a normative choice. And these small differences that we have seen in technical choices can have tremendous normative implications. Because again, this thing is used on the LinkedIn platform, right? It's the platform for job search in this world. And they do not really do intersectionality. I'm not sure if they want to have it that way. I hope so. I hope that they at least like made an informative, like an informed decision. I'm not so sure though. But anyway, and this is the first, the third thing why this is so important, because the values that we encode with these technical choices, they should match the intended values for the task that we have. Okay, we should not just like randomly make technical choices and then have like a very different set of values for this for this task that we are currently looking at. So we really, really have to be very careful what sort of system we install and what are the values that we want to accomplish with the system, and that the system then actually matches these values. And as I was showing to you, it's not that easy to understand it right away. Okay, so with all of this, what do we do? It's mainly asking these key questions. Few of it I have already mentioned. How do we select and design fairness and diversity metrics in systems? Is this something that can be done on an algorithmic level only? Spoiler, can't. But you know, we have to ask ourselves what can be done on an algorithmic level, what is not possible to be done on an algorithmic level. And everything that we can do on an algorithmic level, we still have to check for, is this compliant with the values and belief that we want to encode? And also what is the legal and practical context of use, right? Because some algorithms that can potentially be used in Europe can probably not be used in the US for legal reasons. And again, like what are the values that we want to optimize for? Is it only efficiency? Because very, very often it's only efficiency, but it's not a natural law. We could optimize for something else, egalitarian, for example. Okay, then the next question is like, how do we show that the method works? What methods do we compare? What data set do we experiment on? This is more like research related, but also we have to make sure that there is some sort of evaluation. This was also something that was, as far as I know, not done on the AMAS algorithm, right? Like they were just saying like, okay, we are aiming for more efficiency, but no one ever checked if it's actually more efficient. And then the last question is like, how do we ensure the proper AI governance? Is the first thing is aimed at developers. So we should really be upfront with the limitations of our system and not, I mean, I know this is hard for businesses, but you know, don't go around and tell like, my system is going to solve all of your problems. You just have to click install and that's it. And yeah, of course, another thing is that is the upcoming regulation. That is not my specialty. So I secretly, yeah, I just wanted to mention it here briefly that it exists, but it's not really my field. But anyway, like I think the regulation that is coming up is actually a really good first step. And then we have to ensure that there's these quality standards that are also being worked on that I'm part of. And so, yeah, I think it's a very exciting time to be part of this community right now. And there is a lot of things to talk about. So, and the standardization initiatives, by the way, they are open to the public. So anybody can join. And yeah, so if you feel like you want to join, you have something to say about it, then please join. That's it.
Thanks a lot. I'm joining you. Maybe we sit down and we take this.
All right.
We don't forget.
Thank you. Now I have 2 glasses. Okay.
Good. No, it works. Thank you so much. There was a nice tour around lots of various issues that you described, and it was nice to see that, you know, sometimes seemingly very theoretical concepts actually materialize in very practical consequences. Allow me to start with a question to highlight the relevance of the issue, right? You were picking lots of examples that about, I don't know, hiring decisions. In the background, you had things about discrimination. It's a big topics. Now, some of the people in the room present might be working for organizations that might not lead to such consequential decisions, like life and death questions, like who gets a job and who gets subsidies and support in unemployment constellation, et cetera, et cetera. Do you have examples of algorithms and AI systems where fairness considerations should also be equally relevant, even though the consequences might not be as big?
Okay, I have 2 answers to this. The first one is, in many cases, it's not initially clear how dangerous systems can be. And the best example for me for this is Facebook. Because, I mean, they set out as a platform to rate women. That's not very nice. But if it's done like in a sort of local club, then it's maybe not super harmful for the world, but it became a system that has destabilized several democracies already. Right. And this was by the way the algorithms worked. And it was not that anyone intended this, right? Like people were thinking like, I think people engage most. The first thing was the algorithms were optimizing for engagement. And then it turned out people engage the most when they are angry. But I don't think that this was something that the developers foresaw, that they were like, we want to really, really make people angry. They were like, we just want to make people like stay on the platform and be more engaged, because this is how we make money. And so this is the first thing. I think it's not always very clear. And even if you just think about, you know, the news rankings, for example, all of these like echo chamber problem, like all of this seems to be very, very benign on the surface. That's the first. The second one is, I have mostly worked in these like life and death sort of situations, because also there, the question of fairness is actually easier to formulate. And I can give you an example from the e-commerce domain, like from Zalando right now, not that I can like talk details, right? But the point is, if you think about an e-commerce market in general, a platform like Zalando or Amazon or anyone, so you have some market participants, but the platform itself is also a market participant. And so the first thing that you want to ensure is not too much self-preference. That's something that you sort of actively have to get into. You have to sort of like untrain the model to do this. And the second thing is that the definition of what a fair market is in this setting is actually really hard, because the way the things work now with personalization and everything it is not a standard ideal market as in, you know, this economic models where you can assume that all customers take informed decisions or something, because there's like billions of products and you need personalization, but therefore you already steer people towards a certain direction. So this is what is happening now. It's not a fair market now. And if you say like, okay, I need a certain amount of visibility for everyone, but then the question is, where do you stop? But because in a situation where somebody sells pullovers, let's say, it might be okay that the company goes off the market if they just sell stuff that nobody wants to buy. Versus if you are on LinkedIn, it's much easier to argue that, you know, in the end of the day, for society, everybody needs a job. So whatever qualification some person has, you can just show them in the ranking at some point, for example, you know, like it's much, much easier to formulate this. And if you go even in a theoretical sense, and if you think about this, okay, what is the best balance between a free market and a fair market in an e-commerce setting? I find this super hard. I don't have an answer to this yet. And I don't think the research community has an answer. I have seen like 1 or 2 papers who go into this, which go into this direction, but since this fairness definition is so much more relaxed than it would be in a LinkedIn case, it actually becomes a lot harder to formulate it. Yeah.
Can I ask you, I mean, this is obviously not the focus of your presentation. You were focusing on fair and responsible AI and how to make sure that fairness plays a role, but they are obviously also connected to AI, other concerns, yeah, right? Obviously, beyond the sheer effect of bias, you at least use the keyword kind of misuse of AI on your very last slide. And there was this open letter about the risks of AI calling to take this as a very serious issue. Mm. Are you equally concerned about AI, or are you more optimistic about our human ability to deal with AI in a fair and responsible way?
Well, I mean, I'm probably not going to go down this road of this letter, actually, because I see like a lot of problematic things there. In general, I would say, I think that AI is a great tool for humanity. In, you know, it has many, many application scenarios where it can actually make a big difference and where it can make people's lives easier and stuff. But the question is like, what sort of problems do we want to solve? And this is, again, this is also one of the reasons why I think the AMAS is so critical, right? I mean, if they want to have more efficiency in their system, maybe they should start digitalizing their work first, instead of like, you know, classifying every unemployed person in Austria into 3 ridiculous classes. And I think it's much more the question of whether AI will work or not is like, is the question of what problems are we going to solve and whom is it going to help? And I think this will make all the difference, because I think there's a lot of potential for AI to work in a way that is very, very beneficial. Yeah.
Great. I'm sure there are lots of questions, and I think it might be time to involve the audience and the members listening in. Do you have any questions? Yes, please. It might be best if you activate the mic. Yes, please.
Does the size of the group that has to be advantaged somehow matter?
In what sense?
Let's say handicapped versus women versus maybe people of color. And if you have 5 people in that group, 15 in the other group, and 50 in the third group, and you want to give justice to all groups, does the size of the group matter?
I mean, I can tell you about this in a mathematical way for the algorithm that I did. So the size would not matter as long as you have enough candidates to put into the ranking, right? If you want me to answer this in a normative way, I think it would really depend on, first, on context, second, on who the groups actually are and what is their history of discrimination. And because what you're essentially asking, like what should be the quota, or what should be the percentage that should be that we should promote, for example, right? And then for me, it's not so much a matter of the size of the group, but more of how much harm was done to them in the past and how much do we have to compensate in a particular situation. But I don't think that you can answer this in a general type of way, because it's really making a difference on whether you are applying for a job or whether you're applying for credit or whether I don't know, you're thinking about newspapers that are written by particular groups, for example.
If I'm allowed to add something, in my concept of justice, it would matter. So I'm somehow wondering, because we could artificially, well, build very big groups, like the groups without any disadvantage, if there are 10,000 in there. And so just belonging to a group that needs some extra privileges, that would already promote that person to a position, even though with much decisively less qualifications for the job. And so if that's a recommendation for an employer, then you would get what he's supposed to get.
But it really depends on the situation. For example, like one of my roommates was living in South Africa for a while, and they have like very, very strict quotas for Black people. And she said that her, what was it, her sort of stepsister, or like the family she was living with, there was her sister, and the sister also got like a lot of job offers where she was not like super well qualified for. But the point is that in this society, you have so much problems because of apartheid and because of the apartheid past, that I would argue it doesn't matter. You know, you just want to equalize the society, because people, because the differences between, you know, the economic differences between Black and white people in South Africa is so extreme that it's just bad for everyone. And I would say in this particular society, put people somewhere, just let them have jobs so that the inequality in the society goes away over time. So it really, really depends on the context. Like, you know, it's probably a different matter if you talk about Germany, or if you, well, it's not that Germany is not very racist, but anyway, you know what I want to say, right? Like it really depends on the country. It depends on the history of the country. It also depends on the groups. And it also depends on the data that you even have, right? I mean, in Germany, for example, or in the entire Europe, it is actually very, very hard to talk about the race concept in the same way that they do in the US, right? Like the US has a very established idea of what race is, etc. And Europe doesn't even have a vocabulary, a common vocabulary, right? Like Germans talk about migration background, and you can talk about nationality. So the whole concept of racism is bound in Germany to whether or not you have a migration background and what your original nationality was. In the UK, for example, they do have a little bit that is somehow similar to the US. In France, it's again different. And therefore, we don't even have like a common narrative in Europe yet on how we will deal with racism, and also with algorithmic racism, because we don't really understand what racism does in Europe in a unified sense, right? I know I'm doing a lot of like injustice now to social scientists. I'm pretty sure that they know a lot, but you know what I mean, right? Like the algorithmic community, and who tries to incorporate these sort of concepts into better algorithms, is really stuck in this problem that there is no unified data even about this racism problem in Europe, for example. And yeah, and so again, I think it's really tricky. It depends on situation, context, country, history, and everything, and even the vocabulary and the data that you have.
I dare to ask another question if there is, but as soon as you feel inclined to ask a question, please go. You were skipping about one, I think, a crucial part of your presentation, and that was the Rawls egalitarianism. And obviously, I have to follow up here a bit, because I think the main idea of Rawls, without going into the technical details, is that there is this assumption that on a social or societal level, we need to come to somewhat of an agreement about something, right? I mean, of course, in Rawls' concepts, it's hypothetical, but the solutions that you have presented, if I may be a bit provocative, were a bit much focused on what should the coders and the developers inside of the organization do, under the assumption that they somehow care about fairness. What should they do? And then the very end, towards the end, you were closing by regulation, but beyond regulation, shouldn't we have more of a social dialogue about how should we treat differences, and to what extent do different numbers matter or not matter, and what do we want, and Where do we consider the boundaries of luck versus choice? All these tricky underlying questions. Is it time for a more extensive social discussion about these topics?
Well, absolutely. I think one of the problems that the field of responsible AI in the beginning had, that they were reading like half of the book of Rawls, or even maybe like, the Stanford Encyclopedia summary. And then they went like, okay, I'm going to implement that. Okay, fine, fixed it. Let's move on. That was the first 2 years of responsible AI, right? And then there were like some ethicists and philosophers who were also giving, like, at least they were allowed to publish papers in the same conference, but they were grilling us on this, right? Everybody was saying, what you guys do is ethics washing. It has nothing to do with ethics. And they were right. I do believe that you can implement certain ethical ideas into math. So I don't think that is complete nonsense, but of course it should not be the developer who decides this. And this is why I was hammering this point so much about these two algorithms that are so similar and yet so different in their normative frameworks. Because I think what the developers should do is to provide methods that cover various cases, right? I mean, I was always focusing on luck egalitarianism, but it doesn't mean that formal equality of opportunity is something that we don't need. And instead, I think what we should do is that we have this toolbox full of different things that we can use that are really compliant with the different philosophical ideas or social ideas, maybe. And so that then in the end, if developers and companies care about it, that they can pick the right tool for the values that they have. But of course, like the values that they have to, well, companies have to ask that themselves, and society has to ask that themselves as well. I mean, I think, in regulatory terms, this is sort of like a societal debate already, right? Even though it might be a bit too elite here and there. But of course, it should not be the developers who decide what code of ethics gets implemented. And I think my point is really much more to translate what your method does and what framework it complies to, so that we can pick the right one.
More comments, questions, observations? Yes, please.
Thank you so much for the input. I actually have one comment and one question. The first comment would be, I find it interesting that you showed AMAS as an example, because to my knowledge, there's not a single AI or machine learning module within this algorithm. It's still very much biased in a lot of wrong ways, but it's a hard-coded algorithm that is based on weightings, a weighting system, and putting people into categories. But obviously there's some issues with that, as we saw. I'm just referring to that because I can remember the debate on this like 2 years ago.
Yeah, they used a linear regression for it. So it was a very simple model, a regression model, but a regression model is still like a self-learning model, right? It learns the weights. And
but the CEO was even like replying like there is no artificial intelligence in that. It's okay, but anyways, it's just a comment.
I think they were saying this because they didn't want to be like, subject to some sort of legal issues or something, but this is something that we also see in, that I see in my consultancy with the labor unions, that whenever the works councils come to us and they tell us, the management wants to install this sort of tools, and then the management goes like, yeah, but it's just regression, it's not AI. But regression is already a self-learning, it's like a machine learning thing. It's probably not very sophisticated, but it's still a machine learning tool, right?
Okay. Anyways, I remember that, and this is what I want to base this comment on is, they were like, this is something when it comes to bias and the stuff that you showed, that they wanted to identify and classify, for example, as the algorithm that women are lower classified or disabled people. And their argument have been, because the market and the labor market actually is classifying these people of whatever you call less worthy to work, whatever. And they wanted to identify those people to concentrate the measures to those people who are then less ranked. Whoever this, I'm not a spokesperson, I'm not arguing for them. My question is just like, is the bias in the algorithm, or is the bias what the algorithm is working for in that case to identify, because actually the bias is within the reality of the job market, in that case in Austria, and they want to identify the people?
Yeah, this was a question that was also posed to Doris Alhoter a lot, I think. And what she was saying was that the goal, I mean, I was presenting the goals of the algorithm, right? They were not to help people who are discriminated on the job market. They were setting out for more efficiency. So I think, you know, then after all of this happened, saying like, yeah, but this is actually the reality. And now we have identified the women that are, you know, that have it hard on the job market. That is, it feels funny, honestly. So if they would have said this in the beginning, like we have set out to identify these people, I think it would have been a different story, because, and then what Alberta said was they were mixing up, you know, your qualification with your employability. And this is not the same thing. And I think just because the labor market is discriminating doesn't mean we have to, you know, perpetuate this sort of stuff. And the question is, does a woman who has the same qualification and the only difference is her gender and that the fact that she is a mother, or maybe the other dude also has caregiving duties and we just don't know about it. I mean, this is like already the way the features were framed is, I think, it speaks a lot about the values that were in the heads of the developers. That now I sort of lost what I actually wanted to say.
No, but that's exactly the point. Like the value in the heads of the developers represented the values of the job market and the people actually working there, and they transferred those values into these algorithms. But this is just a comment. I actually have a question. I'm sorry. Okay. So the question would, because I mean we touched it because you obviously already also I think I heard in the introduction are active in the effects of the labor market and what it has for people in the labor market, AI. And we hear it constantly. And I think Zalando was 2018 when they let go basically the whole marketing department, where they introduced like machine learning and AI algorithms to do the marketing for them. What is your answer actually? I mean, you haven't been there at the company. It's not a criticism to you directly, but what is your answer to like the issue that we have in the current system where in the end, Zalando added way more job that they let go. It's not a criticism, but the issue is still there. How do we actually what do we do with those people who don't have the skill set we have to let go because of this AI technology? Thank you.
Yeah, that's a very hard question because you obviously have to do something with them, right? I mean, I don't think that the answer is not to install them, because I think this is just unrealistic. I also don't think that ChatGPT is the new steaming engine, honestly. Like, I mean, it is very sophisticated, and I also can see like quite a lot of use cases where it can help a lot. But at least from what I'm reading in the media, is like, okay, half of the people are going to be jobless in 10 years. I don't think so. So the question is like, what do you do with these people that actually will become jobless? But the question to me is, and it's still an open question to me, like, I don't actually know who this is going to be. Because even if you say like bookkeepers or coders, like it's not entirely true. It's not true that, you know, even with the GPT-3 and GPT-4 models that you can just code whatever without having somebody who has at least a little bit of a skill set on how you would write a website, for example. And then there's all sorts of sophisticated attacks that you can do there, et cetera, right? Like, I don't think that coders will be like having problems in the near future. And yeah, I think it's a tricky question. The question is also like how things are actually going to develop in a way, like what skill set will be needed and what will not. But I also think that there is a lot of panic that is going on in the media right now, like, and a lot of unnecessary, I don't know, overestimation of the ability of that thing. Because again, very impressive, but it's also a lot of blah, you know, like, so, and I think there is, the thing is there's some really pressing issues right now already, like, you know, the copyright issue, for example, for artists and I mean, but it always has these two sides, like there's a lot of artists who use Gen AI for their work and they love it. But of course, I understand that if there is an artist who has like put their work into the internet to be visible, because otherwise you cannot be an artist, right? If you're not in the web. And now some company just randomly crawls this and uses that stuff to generate art that more or less looks exactly like yours, that's a problem. But I think this is like something that we can really address right away. And the rest about like what to do about people who lose their jobs is something, I mean, it's something like related to what we have always done, right? Like we have to retrain them, we have to make sure they don't end up on the street, but there's quite some very good, the social net in Germany, I would say, is relatively well working. And I also don't think that it will be that many people that will get, that will lose their job because of large language models.
Mm. I mean, just to comment on that, I totally agree. And I think the total jobs added to the job market will be exceeding the ones lost significantly through AI and machine learning. A thesis could be that actually these technologies will also be able to train those people who lose the jobs because of the missing skill set.
Maybe.
Yeah, but I think this is an issue that we talked about. Job agencies should be on their radar because I think there will be some significant implications, even though total number. We also have on the other side, not only the missing people, but the shortage. So we not only should train those people because they don't have the job, because on the other side, they are very much needed.
Yeah. And I mean, there's also like a ton of other jobs where you don't need AI skills for that, where you are desperately needed, right? All caregiving jobs are.
Yeah, sure.
Like, I don't know. I don't think there's a single, like a single area in the moment that does not search for workers. No, like, I mean, even in all of the service, like if you go to the hairdresser, if you go to restaurants, like everywhere. So like right now, I would say it's not really such a big problem.
Exactly. I was about to say, I mean, the problem with these analysis about the impact is that it, I mean, yes, given the fact that there are manual care work, et cetera, we still need lots of people where we are desperate search. It doesn't say anything about the other end of the market, right? Where, I don't know, translators, I don't know. I don't think that we need technical translators anymore. I mean, that's done. And how about drivers, right? There is at least 1 million jobs associated with driving a vehicle around. That's okay, that's not a language model, but it's a thing of 10 years, 15 years. And then there's a certain number of people that are exposed to significant employment risks due to AI. So I'm not necessarily overall skeptical, because there were waves of technical innovations that led to fundamental transitions, right? I mean, 200 years ago, 100% of the population was working in agriculture. I'm exaggerating, it was 90 probably. No, nobody works there anymore. I mean, almost nobody. So we will find jobs, but there will be generations of people that will be hit very hard. And I think there needs to be a social solution and a societal discussion about what do we do with it. Let me maybe close by, you were using an expression that I did find interesting. You used the expression ADM, algorithmic decision making, and it reminded me of a picture that I once saw floating around, and I don't know if it's really authentic, that allegedly dates back to a training manual from IBM in the 1970s. It was a paper copy. This thing allegedly said, a computer can never be held accountable. Therefore, a computer should never take a management decision. Do you agree? And maybe you use that to just close off.
Yeah, I mean, the accountability question is actually an interesting one, right? Like, because the question is like, to what extent do you need agency to be accountable for anything? And then the next question is like, at what point do computers have agency? Do you need like self-awareness for it, et cetera, et cetera? So let's maybe not go down this road. I think algorithmic decision-making is, again, it always depends on the context of use. I think it's in personalization, for example, is, if it's done well, it's a very good way of algorithmic decision making, because you do not want to have all the information available, but you want to have the one that is interesting to you, where you learn things and where you are not ending up in an echo chamber. But then there's algorithmic decision making, where I think the point is that in many cases, when these systems are sold, people are selling them with the argument of efficiency, even though these systems should not be evaluated based on efficiency. And the unemployment service is one of them, I think. it should not be totally inefficient, but you know what I mean, right? Like, I mean, the core value there is probably not cost and efficiency, but something else. And so what we should do is like, we should put algorithmic decision-making systems, if they are optimizing for efficiency into we should put them into tasks where they can optimize for efficiency and where it makes sense, and not into others. And then we can even have algorithmic decision-making systems, I think, in other situations, again, if the values that they are encoding match the situation that they are supposed to work in.
Excellent. I think a hopeful outlook on the future of AI. Thank you so much for joining us. I think we learned a lot. It was very helpful. Thanks a lot.